Welcome back, everybody. Today we're going to prove the Pythagorean Theorem. So the goal of the Pythagorean Theorem is to develop a relationship between the sides of a right triangle A, B, and C. And a right triangle is just a triangle that consists of an angle within the triangle that is 90 degrees. So this is a very geometric proof. So what I'm going to do is actually take this same triangle, create another 3 triangles of the same lengths, and trying to form them into another shape that is familiar, such as a square. So I took that same triangle and made another 3 triangles that are exactly the same as the one prior, and fixed them in such a way so that we create this shape. So what we can say is that this length right here is just the hypotenuse of this triangle, and that equals the length on this side, as well as this side, and this side. And we can say the same thing for the side's length A, and also for the length B. So the next thing we're going to do is actually look at the areas of the several shapes in this diagram. So one main shape that pops out from this transformation of these 4 right triangles is this square in the middle. And we know it's a square because we know that the hypotenuse of each triangle is the same and they form this square. So we could say the area in the middle is simply c squared. Now we're going to look at the area of each right triangle. So if you remember the area of a triangle, which equals 1/2 the base times the height. So if we look at the original triangle oriented in this direction, we're going to say this is B, this is A, and this is the right angle. So simply the area of each triangle is 1/2 A times B, A being the height of the triangle. So we could say that this is 1/2 A times B, as well as the other 3 right triangles have the same area. So there's one last shape, and that's the shape of the entire diagram. So what I'm going to say is that this length right here is simply B, and then this length over here is simply A. And we can repeat the same process on this bottom length. So therefore this entire length from top to bottom is A plus B, and then on the bottom it's simply the same thing. Since this length is A plus B and this length is A plus B, that means this big shape going around this square in the 4 right triangles is also a square. So what we can say is that the area of this big square is A plus B quantity squared. So now we're going to create a relationship between the area of the big square and the area of the 4 right triangles and the square in the middle. And that's simply because the area of the 4 right triangles and the square in the middle has to equal the area of the big square. So we can say that the area of the big square equals 4 times the area of one triangle, or one right triangle, plus the square in the middle. So from there we're just going to plug in the values for the areas of each shape. So the area of the big square is simply A plus B squared equals 4 times 1/2 the base times the height plus the area of the middle square, which is going to be C squared. So I'm going to distribute this out, and what we're going to get is A squared plus 2AB plus B squared. And if we simplify this part of the equation, then this is going to be simply 2AB plus C squared. If we subtract 2AB on both sides of the equation, we see that these cancel out. So what we can say is that A squared plus B squared equals C squared. And that right there is the Pythagorean theorem. So therefore from that proof we could say that for any right triangle we could say that the relationship between its sides follows this equation. We can say that A squared plus B squared equals C squared, where A is the leg of one of the sides of the right triangle, and B is the other leg of the right triangle, and C is the hypotenuse of the right triangle. So the order of A and B don't matter, but it does matter what you set those squares equal to, and those have to equal the hypotenuse. And to figure out the hypotenuse is simply the side length directly across from the angle that is 90 degrees. So from here to here, this will always be the hypotenuse. And that is the proof of the Pythagorean theorem. So hopefully this helped you, and I'll see you in the next video.